Hello everyone, this is Robert and welcome to the second part for the Drain Bamage video series. In this video we're going to be talking about weights and dimensions. That's right, super exciting stuff. But I wanted to share with you the whole design process that I go through during every combat robot and quite frankly most projects, so this is fitting as the next video. So please bear with me. I think you might find this video somewhat interesting, and for any of the beginners out there that always ask me, like, how do I make a combat robot? This is how you do it. This is one of these steps. So let's get started. Let me at least explain why weights and dimensions is such a critical step in the first part of the design process. So, as always, feel free to use the chapters to skip around. So why am I starting here? Why are weights and dimensions kind of that first step along the design process? Well, we have to look at combat robots and what we're trying to achieve, right? We're trying to make a combat robot. And for any design project, my first step is always looking at the constraints. Look at the things you can and can't do first. If you're making a combat robot, it has to do A, B, C, X, Y, Z, things like that. And the biggest constraints that we have in combat robots is it's got to fit into a weight class. Sure, you can make a 1 pound, you can make an ant weight, and then it just gets really fat, and you just say, oh, it's now a beetle weight. And that happens quite a lot. But generally speaking, we're looking to at least aim into a weight class. You're not going to hit let's say a 3 pound and be at 5 pounds and then just try and find a competition that does 5 pound bots. It doesn't exist. They don't do that. So you need to design within these constraints. So the weights and the dimensions are very critical, I think, early on in the design process. I think that's the first thing that you need to start looking at. I get a lot of people, I just had one literally like a minute ago. I got an email where someone's like, what motor do I use? I don't know. Use the right motor for your application. Use the right motor that will fit inside your robot, that will be the right weight, that will drive your weapon. How heavy is the weapon? The motor isn't the place that you start. The weights and the dimensions are the place you start. You first have to start and figure out how big the thing is going to be. You're going to need to know what material that's going to be to figure out how big it's going to be and then how much that's going to weigh. So it's a little bit of chicken and egg, but let me go through my process on how I determine all these things as it applies to me making Drain Bamage. Okay, so when I first set out to design Drain Bamage, I knew I wanted it to be relatively small because the smaller it is, the more dense it can be. Definitely more on that later. But generally speaking, you need to start with kind of a general size. If you've never ever seen a featherweight before, you don't know if it's supposed to be that big or that big. So this is kind of where you're going to start. And the easiest place to start is with known values. Generally speaking, you're going to know how much the battery is going to weigh, right? Right out of the gate, you're going to have a pretty good idea of the battery. I think my rule of thumb is like 300 milliamp hours per pound. So like an ant weight will probably have about 300 to 500 milliamp hour battery. When you go up into a beetle weight, it's about an amp hour. And then when you scale up from there, it's kind of roughly like that. I think when you get to a featherweight, it's about like a 3 amp hour battery is generally good. And then when you get to heavyweight, so there's kind of a general scaling. And you kind of generally know what the battery is. So you can say, okay, the battery is going to be this big. The drive, you're probably going to have a pretty good idea of what your drive setup is going to be. So go on some websites, look at the motor, look at the gearbox, look at the wheels, just kind of add that up, and you can get a really good idea of that. Also, generally speaking, for weight classes, you can do this distribution that is something like 30% for the drive, 30% for the structure, and then 40% for the entirety of the weapon. And that'll kind of roughly get you there as well. And you can kind of adjust those sliders up or down. If you don't want to be as weapon heavy, you can say about 30% for the weapon system, and then maybe 40% for the structure and 30% for the drive. So you can kind of work that around. These are all things that you can do before you start picking out the weapon motor, before you start deciding on, the actual weapon that you're doing. So if you're doing a vertical spinner or something, you can generally just kind of allocate, let's say 25 to 40% for the weapon, if you want to go really, really big on that 40%, or about 25%. I think for crippling depression, it was like a 7 pound weapon on the 30 pound bot. So it kind of gives you a rough idea. And usually with a beetle weight, we're talking about about a pound weapon, like on the bigger side, for a 3-pound bot. So you can kind of jot these things down, and it gives you an idea of how much weight you're going to have allocated. And then I start with the known values. All batteries are going to be generally about the same weight for the same capacity cells, things like that. So you can do the radio, you can do the ESCs, you can do the battery. All of those things are going to be generally known because you're going to know what fits for this weight class. So you kind of get all those knowns out of the way. And then for all the things that are variable, like the structure of the chassis, the frame, the actual weapon, then you can kind of use those as variables and then just check them off one by one as you make decisions. So this might sound pretty nerdy, but the very first thing I do for every new design is not open SolidWorks, but actually go into my Google Drive and start a new spreadsheet. It's the truth. I always start with weights and dimensions first. So when I start a new robot for any weight class, like for drain Bamage in particular, I took crippling depression, copied it over, took the things that are going to be shared, because this shares a lot of the same motors and wheels, hubs, shafts, stuff like that. So I took anything that was shared and I just kind of move it over into a new spreadsheet. And generally what I do in the spreadsheet is I do electronics, and then I do drive, and then I do weapon, and then I do chassis or frame, or the actual structure separately. And I kind of give each one of those a percentage, just kind of gives you an idea of where everything's at. If you're looking down at the weapon system and you're like, okay, that's 60%, you can maybe steal a little bit from that. Unless you want to be like a deep six type thing, cool. But it just kind of gives you an idea where that distribution is. And I usually have some column off to the side that's like known or something like that, or have. And basically I'll put an X or an O. If it's something I physically have, like a radio, or I already have the motors, I will weigh them with my handy little scale here, and I'll put an X, that those are a known value. But anything I'm going to be manufacturing or making or can change on the fly, I'm going to put an O in there. And so when I realize that I'm like at 31 pounds, I go and look at all the O's and I see where those are percentage-wise. I usually have a percentage for each one of these, and I can see like, okay, that's really heavy. I'm going to save some weight from that. So you kind of go back and forth, but that's usually kind of the first thing that I do in the design. And it's really easy if you've already made a robot, because you already kind of know what the structure is going to be. You already kind of know what the drive is going to be. And what I did for this bot specifically is I basically took the drive pods out of crippling depression and just put that value in the spreadsheet, just transmitted it right over. So pretty much instantly I knew how much the drive was going to be, I knew what the battery was going to be, I knew what the electronics were going to be. So everything that was left is just the shell. Throughout the initial design process for a bot, or realistically any project, you need to pay attention to your constraints. So in the very first video, I talked about the constraints of like durability, reliability, things like that. And then we also have the constraints of it being a combat robot. So it needs to sit into a certain weight class. It needs to do certain things to be a successful combat robot. And I like to look at the weights as a budget, like a financial budget. I think like I've got $30 and I can spend it this way. And depending on what type of robot you have, you can spend it in all these different ways. If you want to have every single streaming account, you want to have Netflix, HBO, Hulu, Apple TV, and that's how you want to spend your money, cool. If you want to throw everything into that weapon and have nothing left over and be counting the pennies on the counter for the drive, that is totally up to you. You just need to make those decisions up front so that you know what you're getting into, right? So I think this really speaks to that first video that I was talking about, where I need to keep these things in line, because if I started making drain Bamage and I didn't have a clear idea of what the end result was going to be, then that budget just kind of gets spread all over the thing, and the next thing you know, I end up with a 4-wheel drive vertical spinner because, I don't know, I just had money left over and I threw it into a weapon or something like that. So you have to pay attention to it as a budget. And this is where I'm going to anger a lot of people, so get your keyboards ready. But having a weaponless robot basically frees up a lot of your budget. It's kind of like living at home with mom and dad and you don't have to pay rent. You're going to have money left over and you're just going to frivolously spend it on some wedge up front. A weapon system, if you're doing it right, should usually take up about 50% of your budget. And I know earlier I said like 30 to 40%, but think about it this way. You've got the weapon, you've got the support for the weapon, and you have all these other things. Like if I was going to add a weapon into Drain Bamage, I'd need center rails, I'd need some support, I'd need somewhere to hold the axle, I'd need the motor, I'd actually have to double or triple the size of the battery. When you start thinking about this, this only has about a 1 milliamp hour battery because that's all the drive needs, even at 30 pounds. This is normally about a 3 amp hour battery. So it's almost like, I think it's about a pound extra just in the battery than the ESCs. It starts really, really adding up. So you just got to look at this and treat it as a budget. You have $30 worth to spend. Where is all that money going? And if you think about it like that and you realize you're putting way too much money into armor, you're putting way too much money into the weapon, and that's against your design objectives, well, then you go back and cancel a subscription, save a little bit more money, use a coupon, buy something on sale. But that's kind of how I always approach it, is I will oftentimes in my videos even talk about it in terms of being costly, as a very costly thing. This screw costs a lot of money because it's too heavy or too long, or I'm not using carbon fiber, I'm not using aluminum. If you use steel, it's too heavy on the budget. So something to consider. So continuing with this theme of budget, I want to title this chapter, Air is Expensive. It is very expensive from a weight budget standpoint to put air inside your robot. I see a lot of these really old robots, kind of back from the Robo Wars days or whatever. And those bots always are like these big sheet metal boxes, and there's always a lot of air space inside. Air is very expensive. Let me give you an example. So this is the mock-up right now for Drain Bamage. And I'll get into this in the future videos, but this is just kind of the 3D printed mock-up. And this is just to show you how big it is. This is kind of like, okay, this is what the size is going to end up being. For this, every half inch, every 12 inches, if I wanted to add a half-inch air gap inside of here, is a pound, or about 460, 470 grams. That is for every half an inch. So if I can't fit things in there, I want an extra half inch this way or an extra half inch that way, it's going to be about a pound on the full 30 pounds. And once you start thinking about it like that, once you start thinking about it as a cross section, just making the bot smaller, think of what that slice, if I was going to slice a piece right through the middle of it right there and hold it up, put it in SolidWorks and see how much it weighs, it actually ends up being fairly expensive in terms of your budget. So just adding an inch, actually adding an inch would be at 2 pounds. So you just got to start thinking about that. And you can think about it like, oh, it cost me a pound or it cost me 2 pounds. But the other way to think about it is now everything has to be that much thinner. I want to say that this top access panel is like 2 or 3 pounds. Think of how thin that would need to be if I needed to shave 2 pounds off of it. Obviously, I wouldn't just take it off of the one piece, but it's really something you got to think about, is if you're having issues getting to weight, see if you have any air in there. See if you can make anything slightly smaller. You'd be surprised just taking something in by 1/8 of an inch, 1/4 inch, 5 or 6 millimeters, just moving it in, consolidating things, you might save a fairly sizable fraction of your weight budget just by getting rid of air. So whenever I see these bots that have a lot of dead space inside, like Tombstone is a good example if someone is very successful. I'm not criticizing any erased bots, but there's so much air inside of there. If that body was smaller or somehow more compact, everything could be a lot thicker and he'd have a lot more weight left over for other things. So if you're trying to stay really tight with your weight budget, look at air, get rid of air, and that will give you more of your budget to play with. So how did I apply all these principles and experience to Drain Bamage? Well, quite simply, I knew that for Drain Bamage, I was going to be taking largely the drive system out of Crippling Depression, putting it into a large metal shell, and that was pretty much it. So I picked the battery based on what I know from crippling depression, how much the drive ended up being. I knew that I could be at a 1 amp hour battery, so threw that weight down. I knew that I'm going to be using the same ESCs, already had weight for that. I ended up switching the motor, but it's generally the same, just a different configuration, but generally the same weight, same gearbox, things like that. So I basically just took all the weights from that over. So this is a nice luxury because I already know what all these things weigh. Took that over and then decided that I was going to redo the drive system to be as small as possible. And that is the next video, by the way, is the drive system. But I basically knew that I was going to go from a 4-inch wheel down to a 3-inch wheel, retooled the drive pods, the drive systems from there, kind of threw them down on paper, got a good idea of where they would end up being. And basically we end up with this. So this is a simplified, slimmed down version of the drive that is in crippling depression, but instead of the weapon motors or the drive motors butting up against each other like this, they kind of went like that, and there was a space in the middle for the battery. Now they're kind of like that, and the battery is in the center, as you can see. So I ended up with this cool little thing right here. So this is the whole drive module, and yes, it will be floating in the inside just like that. And from here, I knew what my outer bounds were. I know what the overall thickness of the bot is, and I know what the width, length, depth, however you want to say that. I know what these other dimensions are now because this is kind of a constraint, and I can just build a frame around that. And what this has told me is steel is possible. This is the big decision. Do I go with aluminum or do I go with steel? And with this, I can just simply make a shell, right? In SolidWorks, I can say there's going to be an equal offset on the bottom and the top, or whatever each one of these is. So I'm saying, okay, I'm going to do a 1/4 inch offset on top and bottom, and I'm going to do a, let's say just a 1 inch on the outside. What is the weight of that box? And when I looked at it in aluminum, way too light. I think I would need like 2 or 2.5 inches or more with aluminum, which I totally could do, but that's kind of maybe against the original goals. So it showed me that I could end up doing steel, and that's ultimately what I want. I want something that just sucks to hit. And I think I ended up at around 17 millimeters inch thick of steel. So that is fantastic. That's a very, very thick skirt of steel around the side of the thing. And that's essentially what you're seeing here. This is the kind of mock-up and prototype. It doesn't really look super thick at the thickest, but this is up to about 17 millimeters, and it's about 15 millimeters at the edges. So this will be a solid block of steel. I think this is going to weigh about 20 pounds. This is going to weigh about 3 to 4 pounds. And so this whole structure right here is going to end up being about 24 pounds, which leaves me 6 pounds for all the guts and internals. So pretty cool. So I think the next obvious thing to talk about in the next video is the drive. So I'll go into the full details on how I kind of came up with this configuration, but there is one thing that I want to leave you with since this was a relatively boring video. Let's look at a comparison between the guts and the drive on this versus crippling depression. So I've got crippling depression right here. And first off, let's scoot this over. You can get an idea of just overall size. That is the entirety of the size of drain Bamage, at least proposed. So it is significantly smaller. And keep in mind, this doesn't have the weapon on. This guy has like a 7 or 8 pound weapon too. These are going to be the same weight. So this can almost fit on the inside. And if we look simply at the drive, it can kind of fit in between the frame rails. Now keep in mind the wheels are inside here as well. So, you know, when you kind of line it up like that, the whole back half of the robot is not there. If we line it up kind of like that, it's, I'd say about, what, 60% of the width of crippling depression. And if I take into the wedge, it's, you know, less than half. Like, let's look at it like that. So this is on the end right here. And then if we go all the way back to the edge, it is a very, very tiny, tiny robot. So that'll be kind of interesting. But this is what I was talking about in the weight section. For this bot specifically, it being small was a critical design consideration. The smaller I can make this, the thicker and denser this can be. And this is the whole feature. So I want this to be thick and robust as possible. So making everything as small and lightweight as possible is the goal. So I should have said this somewhere earlier in the video, but thank you PCBWay. PCBWay is the sponsor for this project and this series of videos. PCBWay does a lot of different things. They do obviously PCB manufacture, but they also do machining, 3D printing, and some other stuff like that. And they are very reasonable. They have an online upload tool that you can see the price in real time, which is kind of nifty, and I actually used it quite a bit for this project. They are the ones that are making this possible. No ifs, ands, or buts about it. If they weren't sponsoring this project, I would not be doing it, because machining this is not something that I can do in-house, and it is a significant cost to this whole project. So thank you PCBWay for your support. I have some links and information down below. If you're looking to get parts custom machined, check them out, at least get an idea of what it would cost. So that is all I've got for this video. Thanks for bearing with me. In the next video, we're going to be talking about the design for this kind of drive module. And I did want to include this video because it is a critical part of the design. And as I said earlier in the video, so many people want like this 3-part series on how to design and build a combat robot. It's not that simple. There's a million little things that you have to know, and no one really talks about this. No one really talks about, okay, well, how do I decide how big it is? How do I decide how to, get it underweight? This is one of those discussions. This is kind of those, the less pretty aspect of combat robots. We're going to be talking about all sorts of those things. Like I've already done a video about batteries, but we're going to talk about chains a little bit, because there's actually a chain drive in here. Like, what are sprockets? What are chains? How do those work? So I'm going to be including a lot of those things that people kind of gloss over because it's really not as flashy. It's not as good for that thumbnail. It's not good for the clickbait, but it is a necessary thing that you need to understand if you are designing a combat robot. But there will be some cool stuff coming along, like, what is this thing? Yeah, that is a part of Drain Bamage. You'll just have to watch and find out. So once again, thank you PCBWay for your support, and check me out in the next video, and please like, comment, subscribe, and follow me for my upcoming videos on Drain Bamage.